Good morning, class. Today we have a fairly light day as far as the presentation goes because we are not able to do walk the line, um, an activity that was in this section. So I just want to review what we talked about with slope yesterday and get a couple things in our notes. So first of all, the slope ratio is, of course, the change in the y value divided by the change in the x value. And when we see these a lot of times we'll see a table of values and we're going to ask to find the slope based on a table of values. Or we might see a couple of points and we need to figure out what the slope is based on a couple of points. So to find this ratio, we're just going to identify 2 points either from a table or points that we're given. And we're going to look at both the change in y and the change in x. So for example, if I was given these points, and by these points I mean the points 8, 16, and negative 3, 6. First of all, I'm just going to go ahead and identify the change in y. So you can see my y values are 16, and I have a y value that is 6. So I'm just going to write change in y is going to be 16 minus 6. So the change in my y is 16 minus 6. And you can see my x values are 8 and negative 3. So my change in x will be 8 minus this negative 3. 8 minus negative 3. 16 minus 6 is 10, and 8 minus negative 3 is 8 plus 3, so that's 11. So my slope ratio ends up being 10 over 11. 10 over 11. Let's consider another pair of points real quickly, just another example. So here are my points. I encourage you to pause the video now, find the slope on your own. And then again, looking at the change in y, we've got the 6 minus negative 10. 6 minus negative 10 is going to be a positive 16, so my change in y is 6 minus negative 10, which is 16. And then for the change in x, I'm going to have 8 minus 10. 8 minus 10, and 8 minus 10 is negative 2. So my slope is going to be that ratio of 16 divided by negative 2, which is negative 8. So the slope that goes through these 2 points is negative 8. So I expect to see this down 1 over, no, down 8 over 1, down 8 over 1. So every single time x increases by 1 unit, right, y is going to go down by 8 units. It's also possible that we could be given a table of values, and I would like for you to pause the video right now and select any 2 points of your choosing. And based on the points that you have, I want you to, from the points you select, I want you to find the slope. So I don't know if these are the points you selected, but I'm going to select a pair of points. I'm going to select the 10, 6, and I'm also going to select this 16, 9. And I'll write those down here. So here's my points 10, 6 and 16, 9. My change in y is going to be 6 minus 9, which is negative 3. So I've got change in y is 6 minus 9, negative 3. My change in x is going to be 10 minus 16. Here's my x, 10 minus 16. 10 minus 16 is 6. So my slope ratio ends up being negative 3 over negative 6, which is 1/2. So you should have gotten that for any pair of points you selected, even if you selected these points. So make sure that if you didn't get a slope ratio that was equal to positive 1/2, take a look at your work again and verify that there's not a mistake. And remember, we're looking at change in y, change in x. So if we generalize this, right, this pattern that we have, so we have 2 points, and I'm using subscripts here to identify. This is the second point, x sub 2, y sub 2, and this is the first point. And you may say to yourself, Mr. Roberts, you wrote them in reverse order, and I kind of did. It's because I set up the previous examples. I wanted to write it backwards like this. So we know that the slope means that we're going to take y from this point, right? You can see I'm taking y from here, and I'm subtracting y from the other point. So there we go, y at point 2 minus y at point 1. And then here's the x sub 2, and I'm subtracting from that x sub 1. If I clean that up, I want to make sure that you get this into your notes. So go ahead and write this down exactly. And yeah, let's put a star by that. Pause the video if you need to. And we're moving on. So the last thing I want to talk about today is this idea of an association between two sets of numbers. So an association is a relationship between numerical values that can be described by a couple of things. It can be described by its form, its direction, its strength, and whether or not it has outliers. And we're going to talk about all four of these: form, direction, strength, outliers. So if you were going to structure your notes, I would have the word association between, I would just say association between two sets of numbers, association between two sets of numbers. And then the first thing we'll talk about is form. So the shape of the pattern is called the form of the association. And for now, we're going to be considering associations that are either linear or ones that we will call nonlinear, right? So our form, as far as we're concerned right now, is we've got a linear form or a nonlinear form. If one variable increases as the other variable increases, the direction is said to be a positive association. So under the word direction, we have positive association and we have negative association. And we can also say if there is no apparent pattern in the scatter plot, then the variables have no association. And I don't know why, but from your textbook, they definitely show that there's a direction here, right? This looks linear, and it looks like as x is increasing, y's are decreasing. So this is a negative linear association. They're using the word linear because its form, you can approximate this with a line. This next one, they're saying this one looks nonlinear. Like it looks like there's some kind of a curve in here, and it's a negative nonlinear association. And then the last one they have is a positive linear association. Positive linear association. And they're saying it's got some clusters. There's a cluster of data here and here. But in general, if you look at it, it appears that a line could model this data fairly well. Okay, so again, we've talked about form and direction. Now we want to talk about the strength. The strength is a description of how much scatter there is in the data away from the line of best fit. So here's three examples below. If we're talking about the strength, we could say this is very strong. If you look at it, these data points are very close to the line of best fit. There's not a lot of scatter away from that line. So this is a strong, and it's negative because it's decreasing, right? As x gets bigger, y's are getting smaller. And you can see right here, for this particular x, there's y. If I increase x, this y you see is lower than the y before. So as time goes on, the y's are getting smaller as the x's are getting increasing. This we would call a moderate negative association. So you can see there's a lot more scatter, and there's a lot more what we call residuals, right? There's distances between the line of fit and each individual data point. So as there's more scatter away from the line of fit, we say this is a moderate negative association. And then finally, this looks like it's a weak positive association. You can see there's even more scatter away from the line of fit. And instead of being an apparent negative relationship, right, it appears here that as x's are increasing, y's are tending to increase also. So that's why we're using the word positive. And then finally, an outlier. So an outlier is a piece of data that does not seem to fit the overall pattern. There is one obvious outlier right here at the graph. The rest of the data is fitting some exponential curve, but that one particular data point appears to be an outlier. Okay, so that's it. So that is it. There is no lesson check today. All I want you to do is make sure you spend a good amount of time carefully doing the review preview, and I hope that you've got these notes down. That's it. I'll see you again tomorrow or Thursday in class.